Jai Hind, my name is Vaishali Deshwa and I'm working as an assistant professor at AKGEC. So today the session is about machine learning techniques and the code for this is KAI 601. The syllabus is as per the AKTU syllabus and let's start with some of the contents. So in these slides, we'll discuss then what is learning, what are the different types of learning, what is the well-defined learning problems, and how to design a learning system. So first is that what is learning. So learning is any process by which a system improves the performance with experiences, and it denotes the changes in a system that enables the system to do the same task more efficiently next time. And we can say learning is a change in knowledge, skills, behavior, which outcomes is an experience. So with experience, a system is improving, and this process is known as learning. Next, we move on to machine learning. So this is the basic definition of machine learning. It's a subfield of computer science, or we can say that it comes under AI, artificial intelligence. So it evolved from the study of computational learning theory and artificial intelligence. So according to Arthur Samuel in 1959, it defines machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. And in machine learning, any task a machine improves its performance with experiences. So this is somewhat same as we have studied in learning. Next slide shows a diagram. There are two figures in the slide. First is about the traditional programming, that in the first diagram, as an input we are just feeding data and program to a computer and we are getting output. So this is the traditional programming, that you are just feeding data and program to a computer and you are getting output. In second figure, as you can see that this figure represent the concept of machine learning. So in this data and experiences we are feeding or we are giving as an input to computer, and we are getting program with which we can solve the subsequent task or the different type of task. So there are several definitions of machine learning given by different researchers, and some of them I listed here in this slide. So first is learning is any process by which a system improves the performance from experiences. And there is a book written by Tom Mitchell. So he gave several definitions of machine learning. So one of the definition is that he just listed three things, that is P, T and E. P stands for performance, T stands for task, and E stands for experience. So he says that machine learning is a study of algorithm that improves their performance with performance P at some task T with experience E. So the three things that are very important in this. First is P, T and E. So a well-defined learning task is must have PTE. So a learning task is said to be a well-defined learning task when it has all these three things, or when we are able to just identify all these three things, that what is the P, what is T and what is E. Moving on to the next slide. So this slide shows a figure. So in this, the machine learning, the field of machine learning is divided into three categories. First is supervised learning, then unsupervised learning, and the third is reinforcement learning. So the keyword or the key point which is different in two categories, the supervised and unsupervised, is the labeled data and unlabeled data. So in supervised learning, we are giving or we are using labeled data, means we have input and the corresponding output also for that particular input, and in unsupervised we have unlabeled data. And in reinforcement, it's a model that takes action in the environment, then received status updates and feedback, and on the basis of that it improves. Like if it is getting rewards, then it will do that particular task repeatedly. And similarly, if the model gets punishment or some kind of penalty, then that's the wrong path, and the model is saying that it should not follow that particular path. So I will discuss each and every category one by one. first is the supervised machine learning. So in this learning technique, we train the machine using the labeled data set, and based on the training, the machine predicts the output. So for example, suppose we have an input data set of cats and dogs, and so first we will train the model or the machine to understand the different features of cat and dogs. For example, the shape and the size of tail of cat and dog, color and the shape of the eyes, the color of the eyes, like the size and the height. Like dogs are taller and the cats are smaller, and there can be different features of the dog and cat. So we'll train the machine or the model. Next, once the training is completed, so we input the picture of cats and ask the machine to identify the objects and predict the output, and now the machine is well trained. So in this, we are just giving the input. We are feeding the machine that this is the feature of a cat, this is a feature of the dog, and we are telling the machine that if this is the feature, then it will be a cat. If this is a feature, then it will be a dog. Means you are providing the input as well as you are giving the output, means you are giving the labeled data. So in supervised learning, this thing is very important to understand, that we feed the labeled data. We feed the machine with labeled data. So it will check all the features of the objects, like the height, color, shape, size, ears, and all of the features. And then it will categorize a particular image, that whether it will fall in the cat category or it will fall in the dog category. So the main aim or the main goal of the supervised learning technique is to map input variable with the output variable. Input variable is usually represented by x. So these are the variables, or you can see the notations x and y. So here the goal of the supervised learning technique is to map the input with the output. Some of the applications of supervised learning are fraud detection, spam filtering, and risk assessment, etc. And there can be many more applications. Then next thing, we have the categories of supervised machine learning. So further, the supervised machine learning can be divided into the two categories. The first one is the classification, and the next is the regression. So in this, we have first we have the classification. So in classification algorithms, they are used to solve the classification problems in which the output variables is categorical. For example, it can be yes or no, true or false, male, female, red or blue. Means there are the categories. It can be 2, it can be 4, it can be 5 categories. So some of the real-time examples of this classification algorithms or the machine learning is the spam filtering, or the spam detection, and the email filtering, etc. Suppose you are just categorizing the mails as that it's spam, that it should be in spam, it should not be in spam, it is important, it is not important. So you are just categorizing the different thing, and that's sort of examples fall in this category. That's the classification machine learning. Some of the popular classification algorithms are random forest algorithm, decision tree algorithm, and logistic regression. So there are two regressions. First is the linear and the logistic. There are many more, but the linear is the basic one, and the other one is the logistic regression. So although the name is regression, but it is used for classification. So and the next one is the SVM algorithm. There is also one more algorithm, that is SVR, stands for support vector regression. So that we use for the regression purpose, but primarily support vector machine algorithm is used for the classification. That is SVM. Next we have regression. So regression algorithm, they are used to solve regression problems. What is the regression problem? Means in this, the target function is the continuous value, it is not the discrete one. So in this, there is a linear relationship between the input and the output variables, and these are used to predict the continuous output variable. Suppose we are having a series of numbers like 4.1, 4.2, 4.3, and so on. But in the classification, the target function should be discrete. Means it should be the categorical one. It can be 2 category, it can be 3. So these are some of the algorithms which fall in the regression. So there can be the simple linear regression algorithm, multivariate regression algorithm. Suppose if you are having more than 2 variables or 3 variables, then that is the multivariate regression algorithm. Then we have decision tree algorithm. In third unit, we'll study that what is decision tree algorithm, and in the first unit itself we'll study little bit about decision tree, but in the third unit is all about decision tree and the algorithms which we are used to solve such kind of the problems. For example, ID3 is there, CART is there. So I'll discuss the ID3 and the numericals on ID3 algorithm. Next we have the lasso regression. So there are some applications of supervised learning. First is image segmentation and second is medical diagnosis. So image segmentation is like supervised learning algorithm. They're used in image segmentation. So in this process, the image classification is used on the different images with predefined labels. So that is the image segmentation. Then in medical diagnosis, supervised learnings are used in the medical field also, and it is done by using some of the medical images and the past labeled data with the labels for the disease conditions. Means it is used to diagnose the condition of a person early. So then the third application can be fraud detection. So fraud detection, such type of the algorithms, the supervised algorithm, they are used for identifying the fraud detection or the fraud customers. Then spam detection is there, that if this email is spam or not. So this is the example of classification, that you can classify the different emails in the categories, like if it is a spammer, if it should come in the spam category or non-spam category. Next we have the speech recognition. So speech recognition, supervised learning algorithms, they're also used in this, and in this the algorithms, they're trained with voice data, and the various identifications they can be done using the same, like voice activated passwords in the voice commands, etc. Then the next slide is about unsupervised machine learning. So this is a second category of machine learning, unsupervised. So in unsupervised, we use unlabeled data. Means we have input only, we don't have the output, the corresponding output for that particular input. So we have the unlabeled data, and we used to train the model with this unlabeled data, and then machine predicts the output without any supervision. So there is no supervision, as the heading itself explains. And the second point is about that the model is trained with the data that that is neither classified or non-labeled, as I've already told you that here we are using non-labeled data, or you can say unlabeled data. So the model acts on that data without any kind of a supervision. So the main goal of such kind of the learning algorithm is to just group the different categories or the unsorted data set according to the similarities and the patterns or the difference between the data set. For example, suppose there is a basket of the fruit images and we input it into the machine learning models. So the images, they are totally unknown to the model, and the task of the machine is to find out the patterns and the categories of the different types of objects. So this is you can give as many examples as like this. Simply in this unsupervised machine learning, we are just using the unlabeled data, and we are training the model with the help of unlabeled data set, and there is no supervision involved in this. Next, we have categories of unsupervised machine learning. So further, there are different categories of unsupervised machine learning also. First is the clustering and second is association. So let's discuss clustering. That what is clustering? So it is a way to group the objects into the clusters, such as the objects with the most similarities remain in one group and they have fewer or no similarities with the objects of other groups. Then there can be many examples. So one of the examples of the clustering algorithm, that you are just grouping the customers on their purchasing behaviors. That if there is a similarity between the behaviors of the few customers or purchasing habits, if some of the customers, if the purchasing habits of some customers are same, then you can group those customers in one cluster. So that is all about the clustering. Now there are some algorithms which fall under this, the clustering algorithms. First is k-means clustering algorithm, then mean shift algorithm, DB scan is there, PCA is there, and independent component analysis. So all these algorithms we use for the clustering algorithm, and they comes under unsupervised machine learning. Second category of the unsupervised learning is association. So association, it finds the interesting relations among the variables within a data set. So the main aim or the main goal of this learning algorithm is to find out the dependency of one data item on the other data item and map those variables accordingly so that it can generate the maximum profit. Now, this algorithm is mainly applied in the market basket analysis, continuous production, and web usage mining, etc. So there are certain algorithms which are specifically used for this category. First is the a priori and AKGEC and the FP growth algorithms are there. Then there are certain applications of unsupervised machine learning. First is network analysis. Network analysis, unsupervised machine learning are used for identification of the plagiarism and copyright in document network analysis. Second is the recommendation systems. So in recommendation systems, with widely used such kind of the techniques, the unsupervised techniques for building the recommendation applications and for different web applications and e-commerce websites. Third is the anomaly detection. So it is also one of the popular application of such type of algorithms which can identify the unusual data points within the data set, and it is used to discover the fraudulent transactions or the fraud transactions. Then fourth is singular value decomposition. So singular value decomposition is used to extract the particular information from the database, and for this we can use the unsupervised machine learning that for example, extracting information of each user located at a particular location. Next we have semi-supervised machine learning. So as the name suggests, semi-supervised, so it has some of the properties of the supervised machine learning and some of the properties of unsupervised machine learning. So it lies somewhere between two, unsupervised and supervised. So it is a type of machine learning that lies between the two algorithms, and it operates on the data that consists few labels. So it mostly consists of unlabeled data set. And the main goal of the semi-supervised learning is to effectively so as we were discussing semi-supervised learning is the type of machine learning algorithm that lies between the supervised and unsupervised machine learning, and the main goal of this supervised learning is to effectively use all the available data set rather than only the labeled one or the unlabeled one. So if the data set is a mixture of the labeled and unlabeled, so there is no restriction that we have to use the supervised or unsupervised. Such type of the data is quite suitable for the semi-supervised learning. So it is effectively use all the available data rather than only the labeled data. For example, it is supervised learning is where a student is under the supervision of the instructor at home or at college, and further that student is self-analyzing the same concept with any other help from the instructor, then it comes under the unsupervised learning. So this is an example which is differentiating between these three algorithms: supervised, unsupervised, and the semi-supervised learning algorithms. First is supervised, second is unsupervised, and third is the semi-supervised learning. So in semi-supervised learning, the student has to, if he is revising himself after analyzing the same concept under the guidance of an instructor in college, means he's taking some help of the instructor also, and he is he's revising those concepts so at home. So such a kind of the example, they fall under semi-supervised machine learning. Third category is the reinforcement learning. It works on the feedback based process, so in which AI agent automatically explores its surrounding by hitting and trying. So there are the two concepts: one is the penalty and the other one is the reward, and on the basis of those the agent acts further, so taking action and learning from the experiences and improving its performance. So agent gets rewarded for each good action and get penalty for each bad action. And hence the goal of reinforcement learning is just to maximize that reward. So if he tries to maximize the rewards, then then the model is trained for the good actions. So in reinforcement learning, there is no labeled data like the supervised learning. The agent learned from the experience only. So this is a basic difference between the supervised and the reinforcement. That in reinforcement, we are just using, or the agent is just using the experience for its learning. Next slide shows an example of the reinforcement learning. So you can take an example of a child or a game. So reinforcement learning is used to play a game, for example, chess game, or where the game is an environment, or the moves of an agent at each step defines the state, and the goal of the agent is to get a high score. So the agent receives feedback in terms of punishments and reward. And here the goal of the reinforcement learning is to just maximize the rewards. So there are some real world use cases of reinforcement learning, and this thing we'll discuss in next video. So till now we have discussed that what is machine learning, what is learning, what are the different types of machine learning: supervised, unsupervised, and reinforcement. In supervised we have different two categories. In unsupervised we have two categories, and now we were discussing the reinforcement. So in the next video we'll discuss real world use cases of reinforcement learning, or some of the applications of reinforcement learning. Okay, so thank you.